The Microsoft Global Network consists of more than 600,000 kilometers of fiber optic and undersea cable systems, more than 190 points of presence in metro locations, and 400 data centers across the world. The Microsoft Azure Network Operations team is responsible for continuously improving availability and throughput of this massive Azure backbone. Microsoft's network demand is expected to increase 10 times over the next 4 years. Traditional automation approaches, reliant on diagnostics, ticketing, and repair workflows, are not keeping up with hyperscale network growth. As networks grow in complexity and volume, the operational burden on engineering teams intensifies, leading to inefficiencies, delays, and rising costs. To address this challenge, the team shifted from reactive automated workflows with human escalation to scalable AI-driven automation through an agentic framework. It introduced specialized AI agents designed to augment human abilities and perform specific tasks within the event lifecycle. These agents operate within bounded scopes and are invoked by a stateful workflow manager that assembles and injects context, ensuring that each agent has the information it needs to act reliably and repeatably. Meet the Microsoft Hyperscale Networking Agentic Operations team. I'll introduce you to 3 of the many specialized AI agents that run the network operations workflow you'll see in the rest of the demo. Each agent has a bounded, well-defined role and hands off to the next, mirroring how a real NOC escalates an incident from detection to diagnosis to repair. Niobe Lee, NOC Manager, a co-pilot-like agent focused on network ops management. Niobe continuously monitors global network health and surfaces anomalies across the backbone, escalates incidents when necessary, and recommends change windows. Integrates with Teams and Outlook for real-time collaboration and decision-making. Think of Niobe as the always-on first responder. She catches the problem at scale and decides when to pull in deeper expertise. PAL Lock, Tier 2 Escalations, a co-pilot-like agent responsible for root cause analysis. PAL is invoked when agents like Niobe need expert-level root cause analysis, specializes in deep reasoning and complex diagnostics using advanced parallel processing models, understands hundreds of hardware SKUs and operating systems, and synthesizes topology, telemetry, and historical data into a clear diagnosis. Is the senior engineer on demand? It turns raw evidence into a confident root cause and a safe, recommended fix. Miles Dyson, Operations Engineer, an autonomous agent facilitating fiber repair. Miles is a fully autonomous agent that independently initiates and manages fiber repair workflows, runs optical time domain reflectometer (OTDR) tests, coordinates with field technicians, and verifies completed repairs, reduces manual intervention, and accelerates repair times. Miles closes the loop, taking the diagnosis and driving the physical fix end to end, hands off. What makes them work? The foundation. Real-world operational data lets these agents act with minimal supervision and high accuracy. Engineered and curated prompt libraries including device logs, historical tickets, and runbooks. A network graph service and network state service provide live topology and state. Niobe and PAL leverage SQL-like interfaces to triangulate alerts and identify affected components. These aren't one-off internal tools. The same agents, Niobe, PAL, and Miles, and the platform beneath them are available to customers and partners through the Microsoft Network Operations Agent Accelerator, so organizations can bring this agentic operations model to their own networks. Let's see these AI agents in action. Jamie manages the Azure Fiber Network and oversees a team of operations engineers and AI agents. In this real-world example, Jamie wants a status on network health for a region. As usual, he collaborates with teams and starts a conversation with key personnel, which includes some of the AI agents. Niobe Lee, the NOC Manager Copilot agent, is asked to summarize health for the region whose span IDs start with WII. Niobe returns a metro summary: 1 critical, 2 warning, 62 healthy. The table provides a quick status of specified spans. Notice that W030 as the 1 critical span, line RX lost, fiber cut flag, and huge OSC line skew. 16 ports down, all traffic halted. Dispatch field crew, run OTDR to locate break. While in the same Teams session, Jamie can then bring in PAL into the conversation to determine root cause and provide deeper insight into what's going on with the affected span. PAL Lock, the Tier 2 escalation copilot, picks up WE03 and runs a structured live check. Its reasoning, is laid out as SAIM. Symptom, acquire evidence, interpret, and match to cause. S. Symptom. Niobe flagged span WIIE030 as fiber cut, traffic halted. A. Acquire evidence. PAL pulls two datasets. Inventory, which is static, device names, DC codes, hardware SKUs. Status. It looks at live telemetry, key alarms, span loss, and reachability, showing CLI is okay, but SSH unreachable. It also drops in the raw alarm and auto gain excerpts. Next, I. Interpret. The near-end device reports LOS and has shut its booster. The far-end device is offline. The OSC link is down, which rules out a simple client optic issue. Measured span loss of 25 dB with 0 received signal points to a break closer to the I02 side, out between the sites. M match to cause. Consistent with a complete fiber cut on span WIE03 day, both line signal and OSC are dark, and the remote shelf is unreachable. Finally, PAL provides some suggested actions. Dispatch a field crew and run OTDR toward I/O. 2. To pinpoint the fault. Keep the booster disabled to protect optics until continuity is restored. Once the splice is complete, re-enable amps and confirm span loss returns to baseline, which is approximately 22 dBs. It signs off PAL 9000 photons paused on WIII303. Diagnostics complete. This is the deep reasoning agent at work. Rather than a generic ticket, it gathers the exact evidence a senior engineer would. Inventory, live telemetry, and raw device logs across hundreds of hardware SKUs and assembles it into one coherent picture. Note the telltale combination. Management reachability is partially up, but the optical layer is completely dark. This is the payoff of the reasoning. The agent doesn't just describe symptoms, it reaches a diagnosis, in this case, a physical fiber cut, not a config or client fault, and hands back a safe, ordered remediation plan. It localizes the likely break and protects the hardware before anyone rolls a truck. Jamie needs to provide a high-level status of the incident to the executive team, so he asks PAL to summarize accordingly. The same underlying facts as the technical live check, but recast for a non-engineering audience. Plain language impact, 16 ports down, no protected path, and a crisp action list. This is the agent adapting its output to the reader. Deep diagnostics for engineers, a business-ready summary for the team, on demand and in seconds. Finally, Jamie wants to ensure the issue is being addressed. He asks Miles Dyson, the autonomous fiber repair agent, whether he's orchestrating the fix. Miles reports, I'm actively tracking span WE030. All three belong to the same ISHIM number 6782. A live workflow table shows 3 orchestrated workflows all running. Run Metro Fiber Path Impact Workflow. Verified the span list and spawned the single span workflow. Run Single Span Impact Workflow. OTDR located the cut at 50.41 kilometers from I02 port 35.59 kilometers from I34. Waiting for the traffic shift-off signal. Run Fiber Agent Outside DC Workflow follow-up email sent to the on-site technicians requesting an ETA. What's happening now? OTDR pinpoints the break at the 50.41 kilometers mark, 14.8 dB loss. The fiber agent opened provider ticket and is auto-emailing for status. The single span workflow is waiting on a control plane signal, confirming traffic has shifted off the span before it moves to repair/restore. One human controllable lever is exposed. Pause email communication. This is autonomy end-to-end. The agent runs OTDR, opens and chases the carrier ticket, coordinates field techs, and waits for the safe to repair signal, all without a human in the loop. So what does all of this add up to? Let's bring the story back to the bottom line. The measurable operational return we get when engineers stop firefighting and start enabling agents. Let's walk through 3 dimensions: our people, processes, and technology. People. Instead of engineers manually fixing every frontline issue, they now enable the agents and only get pulled in when an agent is truly stuck. That shift drives a 40% increase in incidents handled per person. And because agents like Miles run OTDR tests directly rather than waiting on a human, we see a 25% improvement in fiber cut time to repair. Process. Change windows used to mean manual planning and approvals. Now agents propose a safe window and handle whitelist approval, cutting planning time by 70%. And where a trouble ticket once had to be triaged by the NOC, agents classify and route it automatically, a 60% improvement in time to detect. Technology. We've moved from siloed per-supplier EMS and NMS systems, with humans watching screens, to a unified multi-vendor interaction across a common set of APIs, giving us 80% faster root cause analysis. And by redirecting team time toward enabling technology for AI, like our inline OTDR framework, we're putting 40% more time into the roadmap instead of routine toil. This isn't automation for its own sake. Every one of these gains frees our engineers to do higher value work while the network runs faster, safer, and at hyperscale. That's the return on an agentic operations model. And it's the same platform we're making available to customers and partners.